Right, to give you a little problem-solving-y sort of starter to get things going today, I have something a little bit different before we get on with area and perimeters of parallelograms. So here you go. You've got to find the three numbers there that add up to make 113. You could do it just by trial and error, or you could think about it a bit more. So it'd be interesting to see what you reckon. I'll put the answer to this up at the beginning of next lesson. Right, so here's our title for today, calculating the area and perimeter of parallelograms. So a parallelogram, just in case you're not sure, it's a bit like a rectangle. It's a wonky rectangle. So if I was to draw along six, I'm going to do it very similar to what we had yesterday in terms of our rectangle. So I've gone along 6 squares, then I've gone down 1, 2, 3 and across 2 and up there. So the length of this side is the same as the length of that. The length of this side is the same as the length of that. The other thing we can say is this side is parallel to that one. And if we use double arrows, we can show that this side is parallel to that. And the only difference between it and the rectangle is the angles are not right angles. See this one though, this is a acute angle. This is exactly the same as this acute angle, and this obtuse angle is the same as that one. And what do you think that angle and that one might add up to? If I was to cut that out and move it along, it would fit in just there. So it would be angles on a straight line are a half turn of 180 degrees. Just mention that on the side. What we're meant to be doing today is area, aren't I? So I want you to imagine that this parallelogram is sat on top of a red rectangle, and we can just see that much of the red rectangle. The red rectangle would finish just there. Do you notice something about the red triangle and this triangle here? They're the same size. And what that means is, if we say that's 3 meters there, and that's 6 meters along there, the area of the rectangle would be 6 times 3 is 18, and the area of the parallelogram would also be 6 times 3 is 18 square meters. In this case. Now that means that we can have a rule that we can write down. The area of a parallelogram is the base times, what do you think this is called here? It comes from exactly the same language as what we had yesterday for our triangles. Perpendicular height. So if you could write that down, and then I'm going to draw a parallelogram underneath it, and I'm going to ask you to work out the area and perimeter of that parallelogram. So here's our parallelogram. So take a moment, copy it down, pause the video and have a go at both. Right, so I'm about to go through it. So for part 1, the base is 8 millimeters. The perpendicular height is this distance here, which is 5. 8 times 5 gives us 40. The units are millimeters squared, so 1 mark for 40, 1 mark for millimeters squared. And then the perimeter, the distance around the outside. So you can write 8 up there and 6 there and do 8 add 6 add 8 add 6 if you like, or you could do what we did with the rectangles last lesson, and you could say I've got one of those and one of those to add together, and then because I know we're going to get another one of them, I'll times that by 2. So it'll be 2 times 8 plus 6 is 14 is 28 millimeters. Right, so now see how you get on with mixing it up a little bit. So we've got a couple of triangles, one of them right angled, one of them not, and a parallelogram. So pause the video, have a go at doing both the area and the perimeter of these three shapes, remembering your units. Okay. Right, so for the first one, the area is the base, which is 3, times the perpendicular height, which is 5, and that divided by 2. Now 3 times 5 is 15. Half of 15 is 7.5 or 7.5 centimeters squared. 1 mark for the number, 1 for the unit. Perimeter, the distance around the outside, you've got 5, you've got 6, you've got 3. We just need to add those together, and I make that 14 centimeters. When the numbers are really quite small, your perimeter ends up being bigger than your area in terms of the number. When the numbers are big, then the area gets much bigger than the perimeter. Let's see what happens here. These numbers are a little bit bigger. So the area, this time, it's 12 for the base. The perpendicular height is that 4. So 12 times 4 divided by 2. So 12 fours are 48. Half of 48 is 24 meters squared. Let's put a gap down there. And then the perimeter is the ones around the outside. So now we need to use that 5 and 9 and not the 4. 5 and 9 is 14. Add 12 is 26 meters. So these numbers have got a bit bigger. The perimeter is still bigger than the area, but only by a very small amount, not like twice as much as it was before. Onto the parallelogram, and the area is going to be the base, which is 20. The perpendicular height, that's the red bit here with that little square in the bottom there to show that it's at right angles. So 10 times 20, which is 200 millimeters squared. And the perimeter is the bit around the outside. So you've got another 20 there, another 12. You can do 20 add 12 add 20 add 12, or slightly less work to do if you add the 20 and the 12 together and double it. So 20 add 12 is 32. 2 times 32 is 64 millimeters. So this time the perimeter is a much smaller number than the area, because those numbers are just getting that bit bigger. Right, okay, so we're going to have one more round where I make these look even less sort of easy to work out what it is that's going on. Okay, same rules as before. I want you to find 1, the area, 2, the perimeter for these 3 shapes. Take your time, make a sketch of each one, show all your working, then pause the video and see if you agree with me, or you can understand where I'm coming from, and hopefully you get it all right. Let me know how you get on. And so the area for this one is going to be, the base is actually this one along here, because what we're looking for is 2 lengths that are at 90 degrees to each other. So that's the 10 and the 3. So it's 10 times 3 divided by 2, which is 30 divided by 2, which is 15 centimeters squared. And the perimeter is just the lengths round the outside. So 10 add 7 add 5, which makes 17 plus 5 is 22 centimeters. The area for number 5 is going to be the base and the perpendicular height. So we're looking for the 2 that are at right angles, and sometimes they don't even draw that right angle in, they just expect you to spot it. So 10 is at right angles to that 8. So the area is going to be 10 times 8 over 2. 10 eighths are 80 divided by 2. That's going to give us 40 square millimeters this time. And the second part, the perimeter, the distance round the shape, we've got the 8, we've got 12, we've got 18. So that makes 20 plus 18 is 38 millimeters. And the final one, we've got an area of these two are actually at right angles. So my base is 30, my perpendicular height is 5. You could call it the other way around. So that's the base, that's the perpendicular height, but I don't think that's a good idea. Anyway, sorry. 30 times 5 is 150 square meters. And then the perimeter, the distance around the outside, well, that's the 30, that's a 9. This one here will be 30, this one here will be 9. So the perimeter is going to be 30 add 9 is 39 times by 2. And that is 78. Oh, I nearly wrote meters squared, just meters. All right, and that is where we're going to leave it for today, because I want you to have that solid in your brain before we look at trapeziums next time. Cheerio, folks.